Hi everyone, this is 61BL, Summer 21 Final, question 6 on min heaps. So in this question, we're basically given a min heap in the form of an array, right? And we have to answer some questions of how do A and B relate to certain values in the heap, okay? Now we're given this heap in the form of an array, right? But we know that to get an array of this form, we would basically be going through the tree form of the heap and taking the elements in level order, right? So if I were to convert this array into a tree format of a heap, I would basically go through each element and start writing them down level by level in the tree, right? So I notice that there's a 1 here, which would become the root. That's the first level. Then I put 2 children for 1 because heaps are binary trees. And I'll put A and 3 respectively in those 2 values. Then 5 and 9 under A, 11 and 13 under 3, and then 10 and B under 5, right? So this is the same heap as the one that we're given in array format, but this will make things a little bit easier to answer this question, okay? Cool. So now the first thing that we have to answer is how does A compare to 1, right? So is it greater than 1? Is it less than 1? Or is there no particular relationship, right? So because this is a min heap, we know that the root element, which happens to be 1 in our case, is the minimum element, right? And we know that there are distinct elements, so it's not possible that A can be equal to 1, right? It has to be either greater than 1 or less than 1 because 1 is the root. We know that it has to be greater than 1, right? So for the first one, I'll say A is greater than 1 because it's a min heap and everything needs to be greater than the root value. Okay, for the next one, we're comparing A and 3. Now we notice that A is in the left subtree and 3 is in the same level, but on the right subtree. Whenever we see something like this, we can't really say much about the relationship between 2 values. The only thing that we know about A is that it needs to be greater than 1. And the only thing that we know about 3 is that it also needs to be greater than 1, which it is in this case, right? But apart from this, we don't know anything about A and 3, right? A could be equal to 2 and still satisfy the heap property because it's greater than 1 and less than 5 and 9. Or it could be 4, right? And still satisfy the heap property because again, it's greater than 1 and less than 5 and 9. So now there's no particular relationship between A and 3 because it could be less than 3 or greater than 3. So for this question, I'll put a question mark because there's no particular relationship. Okay. Next part is asking between B and 10. If I look at B and 10 in my heap, I see that 10 and B are basically the same case in which they're in the same level and they're 2 different subtrees, right, of 5. The only thing that they need to satisfy is that they need to be greater than 5. 10 is already greater than 5 and B should also be greater than 5. But with respect to 10, B can be either less than 10, so 6, 7, 8, or 9, or it can be greater than 10, 11, 12, 13, and so on. So again, there's no particular relationship between 10 and B. So I'll put a question mark for this as well. Okay. For the next one, I'm comparing A and B, right? So now I see that A is higher up in the tree than B, right? And because this is a min heap, I know that for this particular subtree, just the one that I've highlighted, A must be the minimum value, which means that A should be less than B, right? Just for this subtree, if we follow the min heap property, the root value should be the minimum value, and A is the minimum value in this subtree because it's the root. So I put A is less than B for this particular part. Okay, that was the first part.